of our experiment is to investigate the constructive and destructive interference using 2D mapping. Let me explain our experiment is about sound interference. As we know that sound is vibration that can pass through many different substances. In fact, sound requires the presence of a medium. As example, is air. Sound cannot travel in a vacuum. Sound propagates in a wave travel as a transfer of energy, sound energy, within a medium. Here we have two types sound interference. There is constructive and destructive interference. As example, we take two loudspeakers located at a distance for 3 meters from the listener. The speakers are producing the same tone with a wavelength of 1 meter. As the distance are equal, the compression of each wave are reaching the listener at the same time, creating a condition known as constructive interference and antenna. It is for destructive interference example. One of the speakers is moved half a wavelength further away from the listener. The reflection of one of the waves will now reach the listener at the same time as the compression of the other. Following the same additive principle as before, the variation in air pressure now cancel each other out. This is called destructive interference when two signals are perfectly out of phase. Okay, next we learn about factors that affect our experiment. First is distance between the speaker, that is A. Second, frequency of sound source. And the third is noise from surrounding. The apparatus that we use are microphones, sound recording software that is Audacity, two identical speakers, stepper motor, frequency generator application, and the last one is NetBeans software. This part is showing where my partners lab, Haris and Fizo, clean up the table by using the eraser before do the scaling. This is me, Muhammad Mizuddin Mazali. I'm scaled the distance of the two identical speakers and microphone, which is D. We can see at the meter rule the distance of each the white paper is 10 cm. We scale until 40 cm. Then, I scale 4 cm each of all the horizontal lines from the center to the left and right. As you can see just now, Hafizur Ramli, my partner's lab, hold the meter rule at 4 cm to the left from the center. Then, the microphone will follow move 4 cm to the left where the meter rule was hold. After the microphone move, the frequency generator of 4000 Hz will on and the sound interference will record. This video will show how to collect the data from the Audacity. Okay, first, the record button was clicked. Okay, then select the smooth sound wave. Click the analyze button, then choose the plot spectrum. Then choose the peak one. Then record the sound interference in decibel.
Okay guys, before we go into the findings, I explain you a little bit about theoretical. Our formula is x equal to lambda d over a. X is a horizontal distance. Lambda was set by the 4 kHz. D D is distance of mic and speaker, and A distance of speaker. And all if this element in the formula, the data depend on D and X. D was set by 10 cm, 20 cm, 30 cm, and 40 cm, and X in 40 cm each until 11 reading. Okay guys, now I want to show you our graph or experiment. There are 4 main things that I want to say about our graph. First of all, our center X at 0 should be at maximum, but as you can see now, X equal to 0 is not at the maximum, so there must be something wrong with our graph. At the second point, from our formula, at D equal to 10 cm, X at 4 cm must be a maximum intensity, but as you can see there, there's no maximum intensity there. And the third part is intensity. Intensity there, we get the intensity as the D move towards the distance between speaker and mic nearer, the intensity is high. You can see at the graph, intensity of 10 cm is higher than 40 cm. That we get. And the number 4 that I want to mention is the width. As D increase, the width of the graph also increase. But there is no significant change between D and W. There must be something wrong, and I will explain more about it on the next slide. Okay guys, now I will explain what recommendation to improve our experiment. As you can see in this slide, there's a red mark and the circle at the red. That means the window already altered our voice recording. So before we do our experiment, we need to study well on Audacity, and we not study well on that. That's our problem. This is because our data is not supposed to that we should get. That's why there is no up and down, no constructive and destructive that we can see there. So we need to study well, and we need to lower a little bit volume of mic at the setting of the window. Okay, and this is the last our slide. For our conclusion of this experiment, we still get constructive and destructive. However, they might be not accurate as theoretical because Windows already altered our sound. So if you guys want to do it experiment to improve your data, you need to study well Audacity and change the setting on the Windows regarding mic. Okay guys, thank you for watching, and don't forget to hit the button like down there.